And today I'm going to talk to you quite a bit about HAcktive Directory forensics. HAcktive Directory in general and forensics. HAcktive Directory is a phrase I sort of coined back in RSA like 5 or 6 years ago when I was part of Javelin Networks, a startup that we sold to Symantec in 2018. I'm essentially a red teamer in mind with the heart of a blue teamer. I really care about blue teamers. And that's what we'll talk about today. So a little bit about myself. I love to play guitars on the world's largest stages. What I really do professionally in parallel to the InfoSec is music and also fly planes. So that's my main passions. But still, I do a lot of hours coding and on the computer with my own firm, my own company, 10-Root Cybersecurity in Israel. I've been around with computers for a while. I'm essentially a hacker, a modem kid hacker from the 80s who grew up with the different technologies, OpenVMS, etc., and discovered Microsoft. Got to work for Microsoft for nearly a decade, from the 90s, 98 to 2007. Pretty much the only security guy there. Pretty much the only guy with the Linux machine, with the dual boot in his machine. I sat there when Steve Ballmer called Linux a cancer and I had Linux on my laptop. That was frightening. But other than this adventure, all my life was more of a freelancer, including, like I said, Javelin Networks, me and a bunch of ex-Israeli Air Force officers and intelligence corps, which we developed a deception solution. In memory, unloaded driver, creating a really unique deception solution in memory for Microsoft Networks. So what we'll talk about? We'll begin with understanding what is HAcktive Directory, why is it so hackable, and why is it that in its third decades, this technology, this identity central management authentication authorization in 95% of all organizations in the world, why is it still so easy to do reconnaissance, lateral movement, credential theft, and essentially privileged persistence in those environments. Then we'll talk about the main part will be how you investigate and build a timeline in terms of forensics and incident response, understanding who did what. When you don't have your logs, all your security logs got wiped, maybe ransomware, most of your domain controllers are encrypted, you only have some backups, quite recent. How do you build all that happened in your network only from this bunch of files? And I'll share with you some open source tools and scripts that I wrote for that. And we'll wrap up. The candy will be a tool I'm working on, quite ready to be released, which detects no agent, nothing through the network, detects pass the hash and golden ticket attacks. So Active Directory is a database, essentially a distributed database, holds all the users, passwords, applications, services, and it is the access control model for Microsoft domain networks. But it's also a technology that, as much as system admins, IT folks love, there is a population that loves it more, and these are attackers, adversaries, hackers. It's really easy, silly easy, to hack your way into an Active Directory domain and from there to get access, privileged access to any application or service in the network. And even in its third decade, Active Directory continues to be a very highly trending risk in environments. So Gartner keeps on having that every year. Also from this year's top risks, identity first security, nation states are targeting Active Directory with phenomenal success. I love the smell of domain admin in the morning, and me and my team, we have a statistic. Our average is around 7 minutes from normal, non-privileged, not even a local admin user, through a set of dozens of techniques that we use locally and through the network to reaching a highly privileged user, getting a shell on your domain controller. It strikes me all the time that even today we find vulnerabilities, CVEs in Active Directory that allow you, like this one, for instance, in late 2020, circa the time of SolarWinds, which also, by the way, SolarWinds also used Active Directory domains as part of its algorithm. This one allowed you zero logon. Probably if you know your Active Directory, you know zero logon allowed you to become from unauthenticated, just having the domain controller IP, to a fully domain admin, fully privileged shell in about 5 seconds. And that was quite a unique one. And this is from recent weeks or months, same account name spoofing. If you can add a computer account, hint, by default, every user can add a computer account. You can become a domain admin. Curb relay app, just from last 2-3 weeks. Universal no fix, so it really cannot be fixed with the default configuration. And Active Directory vulnerabilities are there in every patch Tuesday by Microsoft, including the last one, just from now, this last May, June. So why is AD hackable? So I argue it is a bit like TCP/IP. I think Active Directory, as much as TCP/IP, didn't plan to be that popular. You see, TCP/IP, when it was developed, late 60s, early 70s, it was because of the Cold War between the Russians and America and the States. They needed something to survive. Essentially, the whole thing was availability and disaster recovery to survive like some physical damage, etc. Security was never in the goals or the mindset of TCP/IP to begin with. And this is a bit the same of like Active Directory. Those both technologies got super popular, super common, but they are very far from the threat landscape that they have to deal with. Active Directory was developed, conceived, designed in somewhere in the 90s, mid 90s already the coding happened, so everything was locked in the design. This was before, this was early internet, this was before cloud, of course, before virtualization. Even VMware did not exist back then, not to mention all a bunch of other technologies. And it is involved in every huge breach, and it is the Microsoft mainframe, to say, because it is here to last. I sometimes read some tweets, etc., saying, Azure AD, etc. So Azure AD, by the way, it's a marketing phrase. Azure AD is not really AD, nothing Kerberos held up about it. And the Microsoft mainframe, Active Directory, is here to stay. Even if some workloads will go to the cloud, on the on-prem, it is by far the centralized identity management solution, here to stay and last for several more decades. And compromising your AD really means game over. I think the problem begins with people having much less in-depth knowledge about AD than they think they have, because it is very popular to say, yeah, sure, I know a bunch of tools, and I downloaded Rubius, Mimikatz, and a bunch of other stuff, and Bloodhound, and this makes me understand how Active Directory works. And I'm mainly saying it also not only for red teamers, but also for blue teamers that think they understand their Active Directory. And I'll give you an example in a minute what I'm talking about. So I think at minimum, before you can actually address some advanced topics such as AD forensics, which we'll discuss now, you should really understand and get a good grasp about how identities, authentication, authorization, and the auditing mechanisms work. Realize that AD can authenticate you not only in Kerberos, obviously NTLM is there, and LDAP or LDAP-S, meaning LDAP over TLS is there. Logons versus authentications, the different logon types, that's really a basic thing to get your head around. Understanding that not only users can log in and authenticate, but also computers. Computers in Active Directory are accounts by all means. They have passwords, they can log in to other computers. Exactly, computers can log in to other computers. And if that's something you're missing, then you can be hacked through computer accounts. And of course, security principles, essentially accounts that, objects that can have a SID, a security identifier, that goes to user computers and groups. And authorization is a tricky thing, because normally people would look mainly on group memberships, like is this user a member of domain admins, enterprise admins, etc., but they will miss out the real thing, which is the access control list. And authorization is all about your token, essentially your access control list, or if we want to be specific in Kerberos, it's the PAC. It's the Privileged Attribute Certificate, which is the collection, cumulative collection of security identifiers in your security token that you present to the network. And you can see where this goes. So you can have direct CIS assignment, and you have all kinds of object access types to do different things, like reset passwords, install DS replica, which allows you to add a domain controller. So even if you have 0 other permissions that you will never notice, this very delicate permission is enough to take control of the entire organization. And of course, it doesn't hurt to have some good knowledge of Windows internals. So how processes, threads, handles, security tokens, etc. works, that's That's a basic thing. Few quick examples about what it means to know your HAcktive Directory. So in this example, we have a user, Laura, and this user, as you can see, is a member of essentially one group, marketing. Domain users is a primary group. It doesn't really count, but and also if you will run your default tools coming from Microsoft, so you will get the principal group membership will only contain domain users and marketing, right? And many admins will work by the assumptions that that's what this user can do. Anything that you granted to this user specifically or to the marketing group. But as you would see, this quick parser script I provided for you. So when you will run this script, which essentially enumerates the privileged attribute certificate, so this, by the way, you can do for any user in the domain. So you will see you got 4 groups back: marketing, managers, and development. Where did those groups come from? They weren't in the GUI. They are not in my other management tools. And what you would see if you will dive a bit more closely, and you will consider perhaps the concept of nested group membership. So you will see that the effective group membership really also includes groups that you are part of up there in the hierarchy. So this really means that some permissions that are granted to other groups that this user does not have directly can affect the de facto access permissions that this user will get. Another interesting case is the case of admin SD holder. So the administrative security descriptor holder is essentially a container in Active Directory in your domain. And if you look at this user, in this example here, a user called Kai, so this user does not have any group membership, right? So it just has the primary group, domain user, very simple one, doesn't grant you any specific special privileges. Of course, he cannot access the C$ drive of a domain controller. That's not something he would be able to do. So for your average blue teamer, this user is essentially not a risk, is useless. You know, he can't do anything. But watch out what I can do with this user. I can go ahead and look at enterprise admins, non-arguably one of the most privileged groups in an Active Directory domain in a Kerberos realm. And this group gives you forest-wide permissions. So in a way, it's a bit even more privileged than a domain admin. And I can go ahead and add other users. So I just went ahead and added Ashley, some other user. How can I do that? Is it even possible, given you saw my group membership? So I don't have it in my SIDs. There is no direct SID assignment that allows me to do that. And still I am able to do that. So just think about that. And understand that Active Directory has a set of permissions per object, per property, read-write at the property level, and you should really be aware of that. I love this quote from Ernest Hemingway. The best way to find out if you can trust somebody is to trust them. And oh boy, does Active Directory trust any authenticated user or computer. You see, I guess back in the 90s, it didn't matter much that after you got authenticated, you proved your claim that you are this and that user, then you could, for example, do full reconnaissance, dump the entire DNS zones of your domain, get all the privileged users, where are they logged on from which IP addresses, what was the last time they changed their passwords, what was the last logon of each and every user, and from which IP it happened. So all this information, essentially with some code, you can get all this information freely. And the second point is that not only this information is available with full reconnaissance of your assets to every user, it is also available in a bunch of dozens protocols and APIs. So LDAP, DNS, Kerberos, WMI, RPC, DCOM, OLEDB, ADSI, System Directory Services, ADWS, AD Web Services. These are all just a tiny bit of APIs and protocols you can access Active Directory to query for this information. So there is no surprise that it is a part of any advanced persistent threat, any big APT by nation states, and you can also see it in every ransomware that respects itself. And just have a look at the ports on your Active Directory. Obviously, web services were not invented back then, and nobody thought you could or would want to tunnel something on a single port one way, God forbid. So the ones on the yellow are the sort of mandatory ones that you would expect to see. The blue is also mandatory, but not from every endpoint on the network, but you need it to manage Active Directory from your PowerShell AD module. And the last ones, of course, are also very important. You can maybe minimize this range of ephemeral ports, the high-range ports, up from 49152 to 65535, but still you need them. As if this is not enough, Microsoft kept us confused all the time, us architects, blue teamers, sysadmins, etc. They had a chance to change their mind about what is the best practice architecture, security architecture for AD. In roughly 20 years, they changed it like 5, almost 6 times. So back in the 90s, in the NT4 good old days, the message was the more domains, the merrier. They didn't convey this message because they thought it is good for you to distribute your domains, just because they had a hard-coded limit in their SAM database. Not many are aware. It helps to work inside Microsoft to see it in the code, that there is a hard-coded limit of 40,000 objects that this SAM account database, security account management database, could go to. So they didn't want customers to get a denial of service on creating new objects. But then came NT5, today is known as Windows 2000, and that was the opportunity to consolidate domains. So they pushed all the customers to get all the domains into a single domain. So many geographical domains became headquarters, just one domain. But then they realized, quite a lot due to folks like me and others, that we said, guys, every inside a forest, inside a domain is not a security boundary, it's an administrative boundary. You maybe can manage your policies, password policies, but all domains in the same forests share transitive Kerberos trusts. That's how Kerberos, MIT version 5 Kerberos in Linux, Mac, etc. works. So now that Microsoft adopted it, it was not really sure how Kerberos worked. So in a way, they implemented a mature authentication protocol with a lot of other vulnerabilities, but still without understanding how it works. And then trusts are bad as well, seed filtering, seed history, etc. Then came the Red Forest model, which was very hard to implement and very costly, and it doesn't play a lot along with cloud these days. Admin tier model survived quite a lot, quite some years, and now they're speaking about privileged access. So imagine customers having to change every 2-3 years their entire architecture of their directory services. That's obviously not something that you can do, and that's how we hack organizations. We just use the bad architecture that they implemented like 10 or 15 years ago, and they didn't move from that. That's how easy we go from DMZ to internal network, etc. And of course, to add on top of it, we have the users. Users as the weak link in this chain. You can give them amazing features. You know, no NTLM, you don't get your password in LSAS, just enough administration, which is a constrained, delegated sort of Windows SSH built in, and they don't use it. They prefer to use RDP. They prefer to use to cache their TGTs, their ticket granting ticket everywhere, and just go over it. So now handing over to forensics. So how do you get your hints about understanding what happened in your domain when your domain was hit pretty bad? And I saw it in dozens of incident response cases in the field. And unlike Goldilocks, you know, attackers don't leave you deliberately hints, you know, in your bed and in the soup they drank or the chairs. You just have to grab those by yourself. So in Active Directory forensics, we realized that we're facing a centralized identity management authentication authorization system, which by design has a set of misconfigurations, excessive permissions that we have to deal with. But we still want to build a timeline, who did what and when, and understand the entire reconnaissance, credential theft, group membership changes. And the sources of truth really boil down to like 3 areas. One is a bunch of files. Sysvol is one of the more known one, holding not only the group policy settings, but also other files, logon scripts, etc. The ETW, event tracing for Windows, essentially the event logs of the Windows operating systems, and there's a bunch of them. And pure packet capturing, right? So if you would prepare in advance and you would run sort of a pickup on your domain controllers, you can either respond in real time to some specific patterns in your pickup, or you can, in retrospect, pick up the pickup, and you can get those pieces. But there are 2 files that I encourage you to look more deep into, and those are the NTDS DIT essentially the NT, New Technology Directory Services Directory Information Tree. That's the database file of Active Directory, and a property that exists on each and every object in the domain, which is REPL property metadata. And we're gonna speak about those two. So NTDS DIT is it is the AD database based on a JetBlue database extensible storage engine, just like Wins, Exchange, and some other applications. It comes with a bunch of other files, log files, checkpoint file, etc. And it is managed by a bunch of tools. The most notably one is NTDS util, a command line interface tool that essentially can get snapshots from that database, repair it, do defragmentation, etc. So the database file, unlike, it's not a relational database, right? It's essentially a flat file. It works with pages internally. And these entries that you have there, you can actually access them and see them through a bunch of APIs. If you want to begin to code to that, so I encourage you to begin with ESE NTDLL, or if you're already into some known frameworks, so you have DS internals, which is essentially C# wrap that you can also utilize through PowerShell and stuff like that. But it all boils down to the NTDSA, the Directory Service Agent, which exposes the database through several APIs that you can query. The thing you have to really pay attention to is the database state the database file that you picked up. Because you will see here, for example, I have two different databases from two different organizations, different everything. And the first thing would be to run escntutil/mage on the dit file and just get a dump and some statistics on the header, the checksum, and the state of the database. Was it shut down clearly in a clean state or a dirty shutdown? Because if you will have a non-clean shutdown on the database, it will be very hard to perform many actions. You have to recover pages with a hex editor, and that's not fun. But here you can see I have a very consistent database file. This file is obtained by backups, by taking a snapshot in NTDS util, etc. But let's say you took a snapshot of the database using, for example, volume shadow copies, VSS admin, etc. Many times, if you took this type of snapshot, which would happen during an incident response, so the database you will get will look something like this. It will be in a dirty shutdown state, and you can see that the logs were not fully committed. The last consistent log is like 5 pages difference, 5 transactions different. And what does this mean? The way that Active Directory database works is that changes are written to memory, into your domain controller RAM, and then they are written to the disk cache, if there is a disk cache in some disk, not SSD. And then it's written to a log file, and then the log file, when it feels it's ready, writes it to the NTDS DIT, and then the file is consistent. So while this can happen in a matter of milliseconds, still this can create you a dirty shutdown NTDS DIT file. And speaking about REPL property metadata, so this attribute, essentially, as you can see, it's just a hex decimal. It's just a bunch of bytes on an attribute on each and every object in Active Directory. But it is also represented logically in two different properties, MSDS replication attribute metadata and MSDS replication value metadata as a multi-valued attribute for multi-valued objects. For example, group membership is a multi-valued attribute. And how do I see where in the DIT is this MSDS REPL whatever? So you can see that in this case, you don't find this attribute. It's like Yossi is making it up. You know, you also won't find it in MSDN either. But if I look, essentially, if I pick up the specific property, REPL property metadata, so you see I get back a bunch of bytes, right? So something is really there. It's just not, by default, it's not showing on the object. It's not exposed on the properties by the object that is getting returned. But I promise you that if you specifically ask for this attribute without knowing that it exists, voila, we get back an XML. And keep in mind that when Active Directory was conceived, JSON did not exist, so don't cry because you have to parse XML. But wouldn't it be nice that nobody would have to convert bytes or parse XMLs? Wouldn't it be nice if you had a command line that just parses it all to a grid, and you can filter that grid and see all the changes that happened in your domain. Well, that's exactly what I did. So in this scenario, we're going to search for strings in AD objects, just do a quick scenario, find some renamed accounts that allows us to understand that some user has been renamed since the malicious actions happened with that user, only to discover all logs were wiped, we don't have any logs to work with, and then AD replication metadata will come to the rescue. So first things first, we got some evidence that a user named Annette did some malicious stuff. So we want to get the user, and oops, we don't even find this user under the domain we're working at. Interesting. Maybe it got deleted. So keep in mind that in order to have a recycle bin sort of feature in Active Directory, you have to enable it. It's an optional feature and not enabled by default. That if you want to reanimate or recover objects, so that's something you have to do it in advance. So that's a prior to the incident. But one of the scripts here is a script that finds strings in AD objects. It just goes recursively on all the properties of all the objects in the entire AD structure, and it just finds some matches. In this case, I looked for some Beverly Hills address, but I found just this time format, file time format of on some attributes of password last change attributes. And if I look for a certain string, for example, password, I found a bunch of stuff. All the password replication isn't interesting, really. But at the end, maybe you could see there, we had an evidence that the password reset happened by this user, Annette, at some point in June 2021. So a user named Annette did exist in our environment, so we know that. So maybe it's time to look for possibly this account got renamed at some point. If it didn't get deleted and it is still there, so we will find it by looking for renamed accounts. So that's the next command we're going to run. We're going to look for whatever is remained from our logs, and maybe we still have the set for a renamed account. So we see two renamed actions, event 4781. One is not relevant to our case, and the other is very relevant. We see that it was renamed by some administrative account from Annette to Jane D. And this Jane Doe is essentially the user that did the actions, only it's now under a different name, right? So we have this, this event. I'll just go a bit more into this here. Okay, so the next tool we want to run is essentially looking into the replication metadata history and popping it up to a grid. And this quick script, you can just give it a bunch of accounts, computers or users, and it will give you all the changes that happened since they were the beginning of your Active Directory. And you don't need any logs for that, just the database file. You can also do it offline. The script supports offline and offline online modes. You can see it was created in 2016, this user Jane D. You can see when it got renamed. You can see the that at some point in 2020, it became an administrative, a privileged account, because it got the admin count bit flipped to 1. Essentially, this happens when you are added to one of the known privileged groups, backup operators, server operators, account operators, enterprise admins, etc. And another thing interesting that happened, last change, was it got the seed history populated with a relative ID of 500, meaning that it has a seed history populated with an administrator account from a different domain. This is really not usual. That's something that you should really pay attention when you see that in your AD forensics. So the next script we're gonna launch is get AD group changes. And what this does is allows us to look for group changes in any scope, since the dawn of your domain controllers. Again, either online or offline. Now I'm using it online versus the domain controller that is still on. And you can see here the actual change date and the group that belonged to when it was, the last change was it was removed from backup operators at this time. So this is the time added and removed. So you can see for 2 minutes, right? For 2 minutes, this account was a member of backup operators and then removed. Backup operators essentially is local administrator on domain controllers. This means it can do a lot, quite get you to domain game over. We can also pop up changes for specific groups, obviously. These are all the group membership changes since the dawn of the domain to the domain admins group. And again, I don't need logs. Even if now I come to a domain of a customer that is running Active Directory for more than 20 years and he has no SIM, he didn't do any syslog forwarding, I can still get this data from parsing the raw database file because it is kept in the replication metadata inside this flat file. Just have to know to parse it. And so you see here the changes for this user. And lastly, the thing I want to show you is that this also works in an offline environment. So up till now, everything I've shown you here was on a live domain controller. You can see my AD service interface is responding to a live domain controller. But now I'm flipping over to a workstation that is not connected to a domain, obviously. But also here, I can run this command, get AD group changes, but this time I'm going to use an offline backup, essentially a snapshot taken with NTDS util of the Active Directory database. Note that you don't need any other file except maybe the log files if you're in a dirty shutdown state. But you don't need the system hive. For this, the registry system key you only need if you want to grab NTLM hashes, passwords from that file. So you need the decryption key. But then let's run it now offline. So we're going to use an offline database backup and just point it in the NTDS database dit file, right? And we're going to ask for the user Adam. What this will do, essentially, it will load up. It is an LDAP server, as to say. It will load up the database in memory through some random available high port. And now this instance is loaded on your normal machine or your endpoint, and you can get the information, all the changes, also the replication metadata, all the changes. In this case, I'm showing you the group membership changes. Those are two different scripts that work with the same mechanism of locally loading an LDAP server, exposing you the entire DIT file in memory. And obviously, you can also use one of the fun options is just generate a full report of all groups to a CSV file or to a grid. And this will just dump all the changes that happened in your domain since it was installed into a nice grid that you can search into. And of course, show you when the change was made, and if it's an administrative user, it also gets this bit of information from the database, etc. And here you can filter by anything you want. That was the forensic part. So now, us hackers, red teamers, we keep on searching for this ticket of gold. I don't know whether you are a Neil Young fan or not. The curb TGT hash is something that we are looking for quite extensively. And obviously, even if you don't know much about Active Directory, you probably heard about golden ticket attacks. Golden ticket essentially means game over for the organization. It is relying on obtaining, that the attacker obtains the curb TGT, essentially the master password, the main symmetric key responsible of integrity of all ticket operations, authentication and authorization in Active Directory. And compromising this hash, whether in NTLM, RC4 or AES formats, means game over because you can do offline authentication tokens forging, offline TGT forging, and then you effectively get privileged access persistence. So this curb TGT hash can be obtained in several ways. Obviously not trivial ones, but to a seasoned attacker, they are quite trivial. You can get it through any unauthorized Active Directory application interface. DC Sync and DC Shadow are the known ones, not the only ones. But this really relies on a specific delicate object access permission type called replicate changes all. The other one is obtaining a copy of your AD database, the customer AD database, or a backup. You would be surprised in how many engagements we got a copy of that file from a hidden dollar share of some old backup files that IT thought nobody will see, but obviously you can easily enumerate SMB shares in a Microsoft environment in read-only access, so everyone read allowed, read permission. But you can also, it is already a game over move, but the third option is to steal it directly from the domain controller memory. So obviously, if you're on the DC, any read-write domain controller will give you the curb TGT hash. Read-only domain controllers, unfortunately for an attacker and fortunately for blue teamers, they don't hold the same curb TGT value. They have different curb TGT users with different hashes. And the attack can really be utilized and exercised with a set of parameters and tools. Most notoriously known is obviously Mimikatz, with you can do it with a bunch of different hashes. You can also create it to walk like a duck, look like a duck, etc. So today I'm announcing a tool called Goldfinger, which is essentially a script. It's a PowerShell script, which is PowerShell is probably the best thing that happened to Microsoft. I was beginning to give up on that company, and then they came up with PowerShell, which is you know, the closest you can get to feeling like you're in a normal CLI environment. It works with, it's like, for me, PowerShell, it's like if Python, Perl, shell scripts, Bash, and all went into and .NET went to a motel room. Whatever happened, this blue shell came up running the other day. That's what happened. So it has everything you would expect, all the greps and awks of that you can pipe in and out, and it's also based on objects. So it's the power of objects and the easiness of Bash-like commands. LSPS, everything goes. So it's a PowerShell script. Unfortunately, I wasn't able to finalize it for Security Fest, but it should be ready. I have a bunch of other last-minute checks to fix. But it will detect pass the hash and golden ticket in real time. No agent, no dependencies, no modules. It works with either WinRM, a PowerShell remoting, essentially web services management, or SMB, utilizing the non-commercial PA exec tool. The research really handled a bunch of anomalies to cover all types of suspicious TGTs, suspicious authentication tickets. It supports running as different domains, supports running the entire domain or specific computers. You can also optionally enable WinRM if you want to, especially if you're in a live incident. This can be very helpful because by default, WinRM as a service, a protocol, is not enabled on endpoints, on workstations, only on servers from Windows 2008 R2 and above. I also go ahead and fix some clock skew issues that will give you RPC not available errors. This sometimes happens when the clocks between the endpoint and domain controller gets skew over 5 minutes. So I fix that, and then I get the data, and much more. So it analyzes the tickets, finds the anomalies. And hopefully it will be ready for Hack in Paris. That's the next convention I'm speaking at later this month. And just a quick preview, a quick demonstration. So in this environment, I have on this machine 3 virtual machines, domain controller and other 2 workstations. First off, I'm going to just run the script with the default options. No parameters given. And as you can see, it ran using the default collection methods of WinRM. It found 3 potential computers. 2 of them responded through WinRM. No suspicious entries found, but it did collect 10 Kerberos tickets, and it did save them to CSV. So we're just gonna have a quick look at that CSV and pop it to a grid. And as you can see, so it is essentially, even before the detection, it does, as a free open source tool, doing something that many commercial products fail to do until today. It is also essentially a TGT collector. So you can collect all your authentication, active authentication sessions, Kerberos sessions in your domain and just parse them or look through them, even on a daily thing, even if you're not under fire and under stress. So let's go ahead and do something nice. Let's go and hunt for a pass the hash session. And for that, I'm going to switch over to another VM. This would be the Windows 10 VM. Here I'm logged on as a user named Adam. And Adam prepared in advance the NTLM hash of an administrative user, of SID 500 administrative user. And it's going to just run Mimikatz with pass the hash. So many of you obviously know this secure LSA by Benjamin Delphi in Mimikatz. And what is pass the hash? It's essentially an impersonation token that has a different NTLM hash than the primary token of the process, right? This is the definition. So my primary token is Adam, but the impersonation token, as you can see, the K-list, the Kerberos tickets, I'm coming out to the network as user administrator. This is how pass the hash looks like on the endpoint itself, the compromised endpoint. And of course, you can go and look for and parse events, collect events from the domain, etc. But this is very easier and quicker. So as you can see now, I ran the tool again, and the whole tree lit up. So I found a suspicious ticket. You can also see it in the CLI in the back, but it also opens up in the grid. You see there is a potential pass the hash ticket, suspicious ticket, and you can see the machine it's on, and here you can respond, right? Now you can do some remediation, isolate this machine, whatever you want, and it also keeps a separate report of all the TGTs, but also a separate report for the ones that matched the anomalous suspicious tickets. Now we're gonna create a golden ticket, also by using Mimikatz. We're gonna go back to that same machine, and we're gonna run it, but this time with a different syntax, the golden ticket syntax, which we prepared. And in this case, this really means we're going to use the curb TGT hash, the NTLM hash, and run it. This type of syntax you will see in many articles. That's very common for, and we're going to use the PTT option, essentially pass the ticket. So we injected, as you can see in Klist, we have the administrator ticket in memory injected to this session. And now when we run again the tool, this time we're going to run it with the parameters. We're going to run it with the different collection methods using SMB. SMB is a bit slower because it works with the admin $share, same as PSExec, right? And it has to copy over some files to the temp directory. But now it got us back two suspicious tickets. Obviously, the first one is the one we still have on that machine from previous pass the hash attempt, and the other is the golden ticket. You can see the list of anomalies it found on the golden ticket, right? So everything is wrong. The encoded ticket size, the session session name is not matching the client name. The time difference, the default of Mimikatz is creating for persistence, creating a TGT not for 10 hours, the default, they work in Kerberos, but to create it for 10 years. And now for the last thing, we're gonna create a really stealthy, advanced golden ticket. This means we're gonna walk like a duck, look like a duck, behave like a duck. So this is the closest you get to fooling some network anomalies, pickups, etc. Even if you collect them through the network with some Wireshark or whatever. And let's go ahead and do that. So we have our special syntax on another machine. I switched now to a different machine, different VM, Windows 8-PC. And on this machine, I'm going to run the more advanced syntax of this command. And in this machine, I'm running with a different user, but also a normal user. Now I'm going to run it with these specific options that mess around with the time, beginning, end, and renew. So this will be a ticket that impersonates a real ticket that was given to you by a domain controller with all the rules of the domain you're living at. So we're really making some efforts running the parameters to make this look very normal, right? For an offline forged TGT. But even in this case, when we run again the script, we can play with a bunch of other options just to show you that there are other options. But we run it on workstations only and some verbose that will give us some, and some logging level. Okay, so we're going to also do some extra logging. And as you can see, it found this third suspicious ticket. Now we have two distinct workstations in the red in the back there. that have anomalous tickets. And the second ticket in the list on the Windows 8-PC machine, you can see it has a logon server. Everything's great. It has an AS256-bit encryption key. It has a time difference of 10 and all. Everything looks okay, but still the session name could never match the client name on the Kerberos and have an integrity level of the ticket, because you cannot have the primary token and the impersonation token and the Kerberos ticket at the same time. And of course, there is the log, so you get to see how it ran. So all those bunch of tools and scripts, they are ready for you. You can either pick them up from my GitHub page or from hacktivedirectory.com, and I'll keep on editing this. So to wrap up, obviously, I gave you a chance to see there are many forensic artifacts that you can get, which are very far from being out of the box. But if you pay attention to them in advance, you can really grab them with the right knowledge and open source tools. Keep in mind that HAcktive Directory forensics is a part of a wider picture, right? There are signals coming from the endpoints and some logs in other places in the network and firewall logs, etc. So adopting an event correlation sort of threat hunting mindset, XDRs, etc., can really help to search for high fidelity alerts rather than false positives. I encourage you to practice a before, during, and after approach, meaning essentially before, during, and after an incident. Before an incident, turn on the events that you want, run those tools, get familiar with them. During, of course, you can use them. And in a post-IR, you can understand what are the changes, even if you are missing a lot of information and files. And do check out the pages and the scripts, use them, give me comments, tell me what can be improved. And hopefully that the last tool I showed you, Goldfinger, should be ready by Hack in Paris this month. So thank you very much. We have time for questions?
Yeah, we have time for some questions. I'm sure there are some questions, right? Anyone? Good.
Yeah. The question was, why is this random guy from Israel provided a script that detects this anomalous tickets, and why is Microsoft not doing it for the last 30 years? I phrased your question with your permission. The question is, I would assume because this doesn't bring Microsoft money.
Fair enough.
You know, to be honest, if you buy licenses, E5, whatever, Azure, and you put everything in the cloud, you are signing up to the biggest, vendor lockdown in history, obviously. But, there are reasons to do that. It's not all black and white in the world. I respect that. But yeah, to be honest, I think it's just not in the mindset to provide free tools of an on-prem technology that customers already bought. So you already pay for that. They want to build tools that are for things that you pay in the future. I'm sorry to be blunt, but I think that's the answer. I don't think they lack the knowledge to do what I do, which is essentially pop up a system shell, using multiple protocols, and from the system shell enumerate Kerberos sessions, dump them, parse them, analyze them, and do some research to see the anomalies in the different fields of the tickets. It's not rocket science, right? Flying planes is it's also not hard when you get used to it, but it's harder than writing the script, probably, on the time it takes.
Anyone else? Some additional questions? Come on, don't be shy.
Don't be shy.
It's always that in the first talk of the morning. It's like everyone has to sort of get in the mode to actually dare to say something. Anyone else?
Yeah, sure. Hi. Come again, is it if they are false positive in what?
So do your script find false positives?
Yeah.
Does it happen?
Yeah, that's a good question. Actually, there are cases where you would get false positives. That's why the script is not yet released, because I'm adding an exclusion. Some features I want to add some more arguments to the script is to exclude certain machines. For example, if you run it against an SCCM machine, you will get a lot of false positive past the hash because Manage Engine, SCCM, Exchange, those type of machines, they actually perform past the hash internally. They pop up shells that are impersonating other users, and the primary token is different than the impersonation token. So I want to give you those options in the tool and minimize false positive as much as possible. But to be honest, if you just run it on all your workstations, endpoints, the chances for false positives are very, very rare. It will mainly happen in certain task-specific servers in an average AD domain. But I still want to give you this option. That's why I'm not releasing it yet. So I want to be as customer ready when it is out. But it's a very good question.
Yep.
Yep.
So is this tool something that you could picture a red teamer or an attacker using, or is that sort of a chicken egg question because you have to already own the entire domain to be able to use the tool effectively?
Right. So the question is this a tool that red teamers could also use, or is it like a chicken and an egg question, like you need already the permissions in order to enumerate the Kerberos tickets from each and every endpoint? So it is true. Essentially, every admin tool is an attack tool, right? It all changes in the context that it is ran. It's like any other tool, like a knife. You know, you could prepare salad, you can stab someone. So you can stab someone with the scripts, and obviously use it for reconnaissance, but you would need the permissions first. So obviously you need this script to run with a privileged account that is essentially a local admin on the endpoints, because you need to enumerate all the Kerberos sessions from all the logon sessions on that machine. So in order to do that, you need a token as a system account. And if you already have this permission, you can do a bunch of other things. So running this script as an attacker is less frightening or less worrying, but running it as a blue teamer, that has a lot of value. One of the options is to add also a lapse support, but I'm not sure this will be ready by the end of the month, but I will do my best.
You have one more over there first.
Which one? Sorry.
Same question. Nice
okay.
save. Yep.
Same chicken and egg question. Thank you.
Go ahead.
Right. So you're relating to the last tool, the tickets, the detection, suspicious ticket one? Right. So the question is, if my tool is collecting some information from the KDC, essentially, is it grabbing some settings from the domain controller? The only setting I'm taking from the domain controller, essentially in a simple LDAP query or grabbing it from the sysvol, is the password, the Kerberos policy of the domain to know what is the default time for TGT renewal and how long will be renewed, like the default 10 hours, 7 days. That's the only thing I pick up from the domain controller. The script runs only on the endpoints. So I really don't need anything from the domain controller on the suspicious tickets detection. On the forensic side of scripts, the replication metadata, all history, and get ID group changes, all those parts of demonstration that we had in the middle, those require either an online active domain controller, any domain controller, and or either an offline copy, backup of the database, just the database, no special permissions. So for an attacker, coming back to Dan's question here, that would actually be quite useful because I'm just using a normal user with LDAP queries. So anyone can grab this information. Remember, trust is a slippery thing.
Nice. I think
Nice.
we have to break there because we.
We have to.
Yeah. So
anyway, I'll be available later.
Yeah.
I'll be here throughout the day.
don't be shy.
Yeah, don't be shy. Yeah.
So hand of applause again.
Thank you. Thank you very much.
Yossi.